In this lesson, we are going to be highlighting and reviewing the key characteristics of the absolute value function. Now, this work is going to seem a little bit different than what we have been doing in the last few lessons, where instead we're thinking about the absolute value placed on our regular two-axis xy axis coordinate graphing system. In order to graph the absolute value function on the two-axis system, we need to think about the absolute value function in two variables. And that's what we have up here. So this is a statement of the absolute value function as an actual function. Y is equal to the absolute value of x. Down here, we have a tabular version of what would happen if we were to evaluate that function at different values of x. You'll notice that when we take the absolute value of a number, we get all of those non-negative numbers, 0, 1, 2, 3, 1, 2, 3. For the sake of this exercise, I was just showing you where those individual points are along the way of the graph. And of course, because it's the absolute value function and we're thinking about a number's distance from 0, we can use any number we want in the domain of this function. As we place any number into the evaluation of this function, any real number into the evaluation of this function, we should expect to see any non-negative real number come out as the output. A few things to notice about this graph. First is the symmetry that is over the y-axis. When this original parent function is graphed, we expect the left-hand side and the right-hand side to be symmetric to one another. We don't have symmetry over the x-axis, mostly because there's nothing on the other side of the x-axis. We have nothing down in this space down here because of the absolute value and because of the creation of those non-negative real number outputs. Another thing to notice in this exercise is that the slope is 1 on the right side and -1 on the left side. And that's going to be incredibly important. We are used to graphing lines that continue on in both directions forever, lines that have no real end or beginning, lines that have domains and ranges of all the real numbers. Once we start using the absolute value, we make minor variations to those lines that we're already used to. And in this case, the absolute value forces all of the outputs to be above the x-axis. In a normal set of circumstances, if I was just to graph this as a line, I would graph something like y equals x. And we'll see how y equals x continues all the way down here. But thanks to the presence of the absolute value forces this entire section of the graph to move up here. And we get a continuation of the graph to the left, creating the V shape that we're used to seeing. The absolute value has this key responsibility in mathematics of changing a number to its non-negative version. -1 becomes 1, -2 becomes 2. And we get this whole side of the graph flipped above the x-axis and moved to the top. In the event that we are using the absolute value parent function, we're going to expect to see some changes happen to this graph. We'll expect to see this graph move to the left, to the right, up and down. We'll expect to see changes to the slopes of these sides, and we'll certainly expect to see changes in the direction of the graph.